Hi everyone, Jason from Makera here with another CAM tutorial, and in this one we are looking at how to work with printed circuit boards or PCBs in Makera CAM for the Carvera or Carvera Air desktop CNCs. Makera CAM can import Gerber files to create a PCB, as well as other vector file formats such as DXF or SVG. Before we get into that, there are a few things that you should do to prepare your PCB files for greater success and compatibility with Makera CAM. It is recommended that your line width is greater than 0.2 millimeters, your line spacing is greater than 0.2 millimeters, your via diameter is greater than or equal to 0.4 millimeters, your silkscreen line width is greater than 0.25 millimeters, and that you set your drill unit to metric millimeter 3.3 format. The smallest flat bottom tip tools that can be used are 0.1 millimeter 60 degree V-bits or 0.2 millimeter 30 degree V-bits. It's also recommended to export the line width when exporting your Gerber files, which facilitates Makera CAM's toolpath generation based on automatic nesting. Makera CAM will automatically recognize the solder mask information in the Gerber pad and split it into an independent layer. But if the solder mask layer differs from the actual pad shape on the PCB design layer, a separate solder mask file needs to be exported. And if the top or bottom layer does not contain an outline, a separate outline file needs to be exported as well. Before we import our files, we can actually set up our stock and job parameters in Makera CAM. You could select PCBs as your stock. When doing this, this will automatically select PCB machining parameters for your tools if you select a tool that's compatible with PCBs. We can also adjust the size of our stock to match the blanks that we'll be using to make our PCBs later on. After unzipping a Gerber file, you can use the Import PCB button to select the parts of your PCB file that you would like to import. Each layer in your exported design file will be imported as its own layer in Makera CAM. When importing your PCB file, it is best to import all of your files that you plan to use prior to moving your layers around. This will ensure that all layers are aligned as they were when they were exported originally. But if you need to align different layers, you can use the center to center feature to automatically center and align different parts of your design when needed, such as when working with two-sided PCBs on a separate work coordinate system. You can also use the transform tools to manually move your design around or set specific movements based on positions and different origins within the design. If the exported outline has a line width, it will be displayed as a nested outline frame. The inner outline is usually used with the top or bottom layers for creating your tool paths, and the outer line is used to cut the perimeter in a contour path. We recommend moving the outline to a separate layer to make processing your PCB toolpaths easier to do. For creating your toolpaths, we can start by talking about the traces and paths in your PCB design. We can select the graphics across a single or multiple layers, and we can easily right-click a layer to select all the graphics within it. We want to ensure that the outline is not selected, which again is easier if it's moved to its own layer. We can then create a vector pocket toolpath, and 0.05 millimeters is recommended for a typical cutting depth for copper PCBs. You would typically then use engraving bits for metal with the toolpath parameter set for PCBs, although you could also use a corn bit depending on the size of your line widths. For holes and vias, you can either create a vector drilling operation using drill bits, or create vector pocket operations using corn bits. To cut the perimeter of a PCB to release it from the stock, we can use corn bits to create a vector contour toolpath. You could choose to use tabs to hold the PCB in place when machined, or instead fix your PCB to the bed of your Carvera using double-sided tape as shown in our other tutorial videos. When creating masked PCBs, you can use the solder mask removal tool to machine the pads in your PCB design. Typically, a 0.2 millimeter end depth works well for removing solder mask. And for creating laser engraved silkscreen layers, we can select our silkscreen graphics and create a laser vector toolpath. A speed of 100 typically works well with a power of 20 for light solder mask paste, or a power of 30 for darker color solder mask paste. Remember to use proper safety techniques when operating the laser module as discussed in our other guides and tutorials. And for start to finish PCB tutorials, check out our other guides and videos for PCBs on our wiki site and YouTube channel.